Welcome everybody, this is 8.4 day 1. So we're going to learn for the next several sections here about something called logarithms. Logarithms have been created because they are the inverse of something exponential. And I'm going to say more about that in a little bit, but logarithms are actually very handy when we're trying to solve equations. Just to start off with, we're going to do some fun guess and check action. So I want you to find the value of x for each of these situations. Some of them will be easy and some of them might be tricky. So pause the video and give it a try. At this time you've unpaused, here are our answers. For A, x is 2. For B, x is 2. For C, x is 1. Did you all know that one off the top of your head? Remember from chapter 7, anything to the 0 power is equal to 1. D, did anybody get this one? It's actually -3. To make it so that I have a number in bottom of a fraction, I got a negative exponent. Try it in your calculator if you don't believe me. E, x is 2/3. And F, trick question. X could be any real number because, again, anything to the 0 power is 1. Now here's the deal. These I made so that we could easily do them, but if you didn't know what the power was, we could use something called a logarithm to find it. So let me show you, let me say more about that, and I'll do it under this next section. So we know, for example, that 2 squared is 4 and 2 cubed is 8. But what if I had a problem and my answer is 6, and I know it's 2 to the x power equals 6, and I'm now trying to solve for x. The question is, what is x? Well, 6 is between 4 and 8, so we know that the x has to be somewhere between 2 and 3. At this point in your math life, your only way of getting this would be to do some guess and check action. But a logarithm solves for an exponent, and using a logarithm we can figure out what that is without too much trouble. Let me show you this. If I have if I have something in what we are going to call exponential form, here's how it translates to a logarithm. When I say logarithm, we're going to represent that by log. I'm going to have a little number down here, which is the base. And this is translated from this over here. So the number right next to the log is a y. And I want to point out something. This little number is a subscript, so it's little, and then the y is just right next to the log on the same line. But that is the same y from here. Last but not least, that is set equal to our exponent x. I'll use purple for that one. So the key thing about a logarithm is that the exponent is always the answer. The exponent is the answer. And this is called logarithmic form. One thing that you're going to be doing today is just converting between the two formats. And I'm going to actually show you later how to solve this problem. We might actually, we're not even going to get to it today. That's going to be more what we're going to learn in 8.4 part 2. Let me show you something really quick though. This part right here, if I converted it to logarithmic form, the base is going to be the base of my log. So that's called the base, that little subscript number. The answer over here becomes that number there, and then the exponent from before is the answer. So the reason this is going to work out is that the x is by itself, and all of this is something that I'll be able to type into my calculator eventually. Let's first just try converting between log form and exponential form. To start off with, I've given you some logs, and we're going to try to convert formats. When I look at this, you need to know that this is pronounced log base 2 of 32 equals 5. So this number we say log base 2 of 32 equals 5. All right, the base stays the base. The answer from before becomes the exponent. And then this number here is the answer on the other side. And if we converted it correctly, this should be a true statement. Is 2 to the 5th power really equal to 32? It should be. Next I have log base 5 of 1 equals 0. My base is 5. The answer from before is 0, so that's the exponent. And then this part over here is 1. Sometimes I show students that these two things kind of crisscross to help you remember that. And again, is this a true statement? Is 5 to the 0 power equal to 1? Check, it is. Go ahead and pause and try C and D. Here's the answers. It seems easy, but you can gain yourself some easy points just by being able to convert between the two formats. Now I want to talk to you about some special logarithm values. And specifically, there's a few special properties that, this is one of them actually. If I know that there's a 1 for my answer, these two are always going to be the same. Let me say more. They're special values, and I also call these formulas sometimes. Here's the first one. If I have log base b, b could be any number, b could be any number, and then it's of 1. So this part here has to be a 1. That's always going to be equal to 0. And the reason is, if I convert this to exponential form, in exponential form it would look like b to the 0 power equals 1. It doesn't matter what b is. Anything to the 0 power is equal to 1. So if there's a 1 here, the answer is 0. The next special formula I want to show you is if I have this base and this number here are the same. If the base and this number here are the same, it's equal to 1 every time. It could be 10 and 10, 4 and 4, 6 and 6, -2, -2. If those two are the same, it's equal to 1. And the reason that happens is because if I convert this to exponential form again, I get this, but anything to the first power is just itself. So that's how that one works. The next property you need to know, or not property I guess I should say, but formula, rule. Let's say now I have log base b, and now I have it of b, but it's to the x exponent. So log base b of b to the x. That is equal to x. Here's why. If I convert this to exponential form, here's my base. This is the part that goes in my exponent from before. And then this part here goes on the other side, and but that happens to be b to the x. So see, these two things are the same, and if those two things are the same, really the bases don't matter, so x equals x and it equals itself. But a shortcut of knowing this is that I tell my students, if you have the base and the number the same, it's just equal to x. Here's another one. If I have a base of b and my exponent is a log, this seems kind of crazy, but the base is b and the exponent is log base b of x, that is also equal to x. For a similar reason to here, if I convert it to logarithmic form, it ends up being log base b of x equals log base b of x. And one other thing is, logs and inverses, logs and exponents are inverses of each other, and they undo each other. Last but not least, I want to teach you about something called the common logarithm. If I have log base 10, it is actually used a lot in different scientific formulas and things. So if I have log base 10 of anything, you actually don't have to write the 10, and you just write log of x. So for example, let's say I had log of 5. Really, that is equal to log base 10 of 5. They just don't write the 10. It's kind of like how, remember in chapter 7 we learned a square root is really a 2 root. They just don't write the 2 because the square root's so commonly used. It's like that. So that's called a common log. Oh, I didn't realize that I remade my notes sheet and we could have put that right under there. Sorry if that just messed you guys up. Let's scroll down and use these properties. And now we're going to use the special formulas. So for each one of these, it's not going to be super fast at first. So every time look back to your formulas and try to figure out which one it matches with. So now I'm trying to solve for x. First I have log base 4 of 1 equals to x. Look back at your formulas, figure out which one this looks like. It looks like the first one I taught you, so the answer is 0. Alternatively, if you don't just know the formulas off the top of your head, we could convert this to exponential form. And in exponential form, 4 is the base. That becomes the new exponent, and that number goes over there. So I'm looking for what power of 4 gives us a 1. The only way you can get 1 for your answer is if it's 0. So x is equal to 0. All right, let's keep going. And now at this point, I'm going to try to do a lot of these just with properties and not with logs. Part B. Log base 80 of 1 equals x. Wow, this is just like part A. If I have a 1 here, anytime you got a 1 there, it's equal to 0. Because remember, the answer is an exponent. So anything to the 0 power is always equal to 1. So anything to the 0 power is always equal to 1. You know what? I wrote that wrong. There. Okay. Part C. Use a second property I taught you. So I've got log base 4 of 4 is equal to x. The answer is 1. Again, if you converted it to exponential form, it would look like this. So 4 to the first power equals 4. Now pause the video quick. Are you understanding how to convert between exponential form and logarithmic form? And I keep saying that over and over again. So if you're not really quite sure, scroll back up quick and look this over. This is what I'm doing every time. I'm just converting between the formats. So look that over right now if you're not understanding. Moving right along though, we're going to look at part D. And I wanted you to get the hang of it, so a lot of these properties I just repeated. So D, x is also 1. Let's look at E. All right, here's my first time I'm using my property of logs. So remember how I said a common logarithm is where there's no base? See how this doesn't have a base right here? If it doesn't have a base, it really means it's base 10. And the reason I care is because now I can use this property I showed you, which means they're basically inverses, which we're going to say more about tomorrow, but basically those cancel each other. And so here, those cancel each other. It's just 2 for my answer. All right, part F. This one requires some thought. Right away, none of these are matching up with any of my properties. Look it over quick, see if you agree with me. We can actually rewrite 9 though. So I can rewrite 9 so that it's 3 squared. And I'm going to just move this around a little bit because those are multiplied together, so I can multiply them together. Now it looks like a property I have. So look back up, see which property it matches with. And again, I'm saying properties, but they're not really properties. They're more like formulas or rules. That whole thing is just equal to whatever the exponent is then, which is 2x. Part G. Actually, this is very similar to part E. It's another one where I've got 10, and then the exponent is log base 10. So that one's just equal to x. Part H is just equal to x as well. All right, that's it for side 1. We're going to do side 2 with video 2. So go ahead and pause, and we'll catch you in a few minutes.